In today's video lecture, we are going to look at thermodynamic cycle. First, let us look at the definition of thermodynamic cycle. Thermodynamic cycle or a cycle is the series of processes undergone by a system such that the initial and final states of the system are same. Let us look at the example shown here. The four processes taking place in a four-stroke piston engine is shown here. At the beginning of the cycle, you have the piston at TDC, right? So when the piston is at TDC, let us assume that the volume is V1, right? When the piston goes to BDC, during the suction process, the volume changes to V2. Subsequently, during the compression stroke, the piston moves from BDC to TDC, and after during the expansion stroke from TDC to BDC, and finally during the exhaust stroke, piston moves from BDC to TDC again. So at the end of the exhaust stroke, the position of the piston will be at TDC, where the volume of the gas inside the cylinder is V1. At the beginning of the cycle, the volume is V1, and similarly at the end of the cycle, the volume is V1, right? That means the system has started from a particular state, and it goes to the same state at the end of the cycle. Or I can say the initial state of the system and final state of the system are same while executing these four processes. So this is an example for a cycle. At the end of the exhaust stroke or after completion of the exhaust stroke, again the suction stroke starts from TDC. So this is an example of a thermodynamic cycle. In a thermodynamic cycle, there will be energy interactions between system and its surroundings in terms of heat and work. Particularly during the compression process, you will have a work transfer between surrounding to system. So I'll write this as compression work. During the expansion process 3 to 4, the work transfer takes place from the system to surrounding. I'll write that as expansion work. During heat addition process 2 to 3, heat is added to the system. I'll write as Q in. And during the heat rejection or exhaust process, heat is removed from the system. It goes to the surrounding. So I'll write as Q out. So in a cycle, you will have a number of work transfers between system and its surroundings. Similarly, heat transfers. So I can sum up all the work transfers. Similarly, all the heat transfers separately. When I sum up the work transfers in a cycle, right, I have to give the appropriate sign for the particular work. For example, WC. WC is given a negative sign because this is the work transfer from the surrounding to system, and I will give a positive sign for WE, work transfer from system to surroundings. Similarly, when I write the summation of Q, I will write a positive sign for Q in, heat transfer from surrounding to system, and negative sign for Q out, the heat transfer from system to surrounding.